Okay, so this is the last lesson in this unit.
What?
So the last lesson is always a problem-solving lesson, so we're going to do a lot of focus on problem-solving today. This is all about, it says draw a picture and write an equation. Okay, to be clear, pictures in math are not, you know, Bobby has a cupcake. Okay, no, that's not a math picture. A math picture is if there are 10 cupcakes and 12 cookies, how many sweets are there in all? This is a math picture, okay? Math pictures are really just ways of setting ourselves up to understand more what it's asking. When I see a question mark up here, I know I need to add those two to get it together. If I see a question mark in one of these guys, I know it's asking me to subtract to figure out what is missing. So when I'm looking at this, it's got a little graph here. It's talking about the different types of brains. Very appropriate for this time of month. It's asking, the mass of a human brain is how much greater than the mass of a chimpanzee brain? So what is it asking me to do? What is it asking me to do?
Subtract.
It's asking me to subtract. What was my key word there that tells me I need to be subtracting? How much greater is my key word? So before you even get started, write this off to the side, please. So addition words. Addition words. And then skip a few lines, like a lot. 1, 2, 3, 4, 5, 6.
1, 2, 3, 4.
And then go subtraction words.
How many lines? 1, 2, 3, 4, 5, 6.
Skip like 6. So when I'm reading problems, there are words that give it away on what I'm supposed to do. With addition, if it says total amount, the total amount is going to tell me what all I'm doing, that I need to add all of it together. That's what I need. Another word that tells me addition is in all. Another that tells me is how much. Another word is some. Another word is all together. All together. No, all together.
What?
It's a beetle, sorry.
Beetle? I know.
So those are all words that our brains should immediately go, up, addition.
Oh, subtraction.
That should tell us right away. So then, subtraction words. The first one that we see the most, difference. What is the difference? Or in this case, how much greater? What's another thing that we would do? What's another one?
More.
How many more?
Yeah.
So how much greater? How many more is about the same, but you know what? They purposely use those different words to trip you up. How many more? Sometimes they'll even say how much fewer, how many less. Mm-hmm.
Oh, I got left. Like how much is left?
How much is left?
Yes.
Would that say that I need to be subtracting?
Yes.
Mm-hmm.
Like 2 more.
So we'll be seeing as we're reading through here, those words. And our brains should be able to determine, okay, that was an addition word, that was a subtraction word. That's going to immediately make your problem solving a lot easier.
What about left and fewer? Aren't those left and fewer?
What?
Aren't left and fewer more words?
Yes, left and fewer.
Wait. What about how much? Wait, we just.
Well, I've got how much greater, how much left, how much fewer. A lot of that is going to be, it's asking those specifics. So let's take that and go with it now. Okay. So it's saying how much greater, which means I'm figuring out the difference, which means I'm doing subtraction. Human brain versus chimpanzee. Human, 1,350. So I'm going to write down 1,350. And chimpanzee, so minus 420. 0 minus 0 is 0. 5 minus 2 is 13 minus 4, 9. So 930. That's it. Because remember, there's no point in redistributing, taking the 1 and making it a 0 and making this 3 a 13. There's no point. I've already got a 13, so I just look at it as 13 minus 4. If I can cut some corners and make things go a little quicker, I'm going to do it. So for number 1, it says Sandy earned $36 from babysitting and $15 for doing her chores. Write an equation and find the total amount that Sandy earned. And it shows you a picture here. So what is this asking me to do? What was my key word? Total. So all I'm doing is 36 plus 15. What's 6 plus 5?
11.
Okay, 1 plus 3 plus 1 is basically 3 plus 2.
5.
So 51. Not bad, right? That's totally manageable.
What about the pictures we did?
So it didn't ask us to draw a picture. A lot of times, guys, is this what I wrote here? This is already here for me. I don't need to draw that again. For me, having it drawn already is what's going to help me even more. Drawing it out myself means I already know what it's asking me to do. And honestly, I'm not going to take that time to draw it unless the actual problem says, draw a picture. I'm like, that's what it says to do. But drawing this out, to me, is not helpful. If I have drawn it like this, that means I know that I need to add these two to get this. Now, if I'm unsure and I have this picture to look at, yes, that's going to help me. But the book will provide that. And the test will provide that. So it's one of those where I just pick, you know what? There are some things I don't need to spend my time on. Like reasonableness. How can you show that 930 grams is a reasonable answer? What on earth do you mean by that? Hello? I just did the math. Obviously, 930 is the answer. So, yeah, it's reasonable because it's right. I don't want you to take the word reasonable very seriously. Usually when it's asking you that, it's just saying, does this make sense? Is your answer right? Now, if they were to say, would it be reasonable to say that it's about 900 more? Yes, because the answer is 930. So it would be reasonable to say 900 more. Would it be reasonable to say it's 1,000 more? No. Would it be reasonable to say that the brain is about 1,000 more? Honestly, yes.
Well, yeah.
If I'm rounding to the nearest 100.
Wait, what? How?
If I'm rounding to the nearest, if I'm turning that 9, 10 is going to make it go down to 900. If I'm talking about rounding this up, 9 can be pretty close to 1,000. When we're talking in the grand scheme of things, $930, a lot of people will just say 1,000. In fact, most people, if something costs $930, will say, yeah, it's about $1,000. And then when you go to check out, like, your total is $930. And the person's like, oh, I saved money. Hooray! And they don't realize that, maybe the people just said that it's about this much and then the actual price is left. And then people are like excited and everybody go buy this because it's going to be cheaper.
Yay!
There's a whole nother world of tactics on how to sell things. We're not going to get into that.
Like 99.
But yes, $9.99 looks less than 10.
Yeah.
Anyways, so I don't want you to be freaking out when you see these reasonableness questions. It usually just means, is the answer right? Or is it close to being right? And then we'll say, yes, because I did the math and here it is. Can we move on? So I'm going to do 4 and 5 with you to demonstrate how to go through these word problems. These things are tricky and they are trying really hard to mess you up. So here's what we're going to do. We're going to read it once and then we're going to talk about what needs to be done. So 4 cities are on the same road that runs east to west. Fleming is west of Bridgewater, but east of Clinton. Union is between Fleming and Bridgewater. It is 21 miles from Fleming to Union. It is 55 miles from Clinton to Union. How far is it from Clinton to Fleming? Okay, my brain's pretty scrambled after reading that. But what I'm going to do now is ask myself, what is it asking me to do? The actual question is, how far is it from Clinton to Fleming? Now, my brain is still a bit of a mess from this, so I'm going to draw a picture here and let me show you how I'm going to work this out, and I want you to do it with me. I'm going to do it one sentence at a time. 4 cities are on the same road that runs east to west, okay? Here is a road that runs east to west. So here's my west, and here's my east. All right, now I'm going to go to my next sentence. Fleming is west of Bridgewater, okay? West of Bridgewater. That means Fleming is going to be on this side and Bridgewater's over here. So I'm going to put Bridgewater right here. And I'm going to put Fleming right here. And then it says, but east of Clinton. Fleming is west of Bridgewater, so it's west of Bridgewater, comes before it. But east of Clinton, meaning Clinton is over here.
How many?
See? So far, we good?
Yeah.
Because Fleming is west, meaning it comes before. But it's east, meaning it comes after of Clinton. Okay. Union is between Fleming and Bridgewater. Oh, so I'm going to put Union right here. You know what? This might not be the most accurate, but that's okay. If anything, I might move my F a little closer here in the middle. But honestly, that doesn't matter. As long as I can visualize what's going on, I'm going to be fine. All right. So now I've got where my cities are. It is 21 miles from Fleming to Union. Okay, so Fleming to Union is 21 miles. It is 55 miles from Clinton to Union. Okay, so Clinton to Union is 55 miles. Can you see it now?
Yes.
Now that I have drawn this out, I have a better understanding of what it's asking me. How far is it from Clinton to Fleming? I need to figure out this question.
I know the answer.
Now, oh, light bulbs are happening. Now I'm going to draw one more picture using this graph to help me. And maybe now you'll understand. Here we go. Ready?
I don't get it.
What is it asking me to do? What is it asking me to do?
55 minus 20.
It's asking me to subtract. Clinton to Union is 55 miles. Fleming is in between that. So I know that Fleming to Union is 21. So Clinton to Fleming is going to have to be the remainder when I've subtracted 55 minus 21.
So it'll be 55.
So now I'm going to do 55 minus 21. What's 5 minus 1?
4.
What's 5 minus 2?
3.
There we go. So how far is it from Clinton to Fleming?
34.
34 miles. That's my answer. So in all, after all that, the actual math problem that I had to do was 55 minus 21. I did not even have to redistribute a single thing. So the actual math it was asking me to do was quite simple. I found it not much of a challenge to get through. Setting it up to figure out what it was asking me to do, that's a whole different story. That was challenging. I had to take it sentence by sentence.
So it's like you try. Oh.
So I'm drawing it out to help myself visualize, because eventually I've realized I've got the whole part right here and part of that hole right here. So now I need the other part of that hole. So 55 miles in all, where one part to one part is 21, and the other part is 34. Part, whole. 34 and 21 makes 55 in all.
So it's just asking you how far it is from Clinton.
So let's go on to number 5. Once again, I'm reading it all the way before I start trying to answer it, because assumptions are what get me in trouble.
What's our assumption?
An assumption is just thinking that something is going to be just that. This lesson's been all about subtraction, so everything in here is subtraction, so everything I will do will be subtracting. No.
No, already did.
You guys got tricked by that the other day with the Mount Kilimanjaro.
What's that?
Remember climbing Mount Kilimanjaro and it was asking the total amount and a lot of you wanted to start subtracting?
Are we gonna do this today?
So, Scott and his friends walk to school together. Scott leaves his home at 7 a.m. He meets Johnny and Zach at the end of the block. Next, they meet Paul, Tim, and Pete. Dan and Tori join them 1 block before school. How many friends walk to school altogether? Okay. First off, what is the question? How many friends walk to school all together? Was it asking me to do? Add, because all together. So literally, guys, it's asking me to add up all the names. So here's what I'm going to do. Does 7 a.m. matter?
No.
No. Does going to the end of the block matter? No. They are trying to mess with your brain and make you think you need to draw some crazy picture. So what I'm going to do is now I'm going to reread it and I'm going to write down the names as I see them. Scott, okay, and his friends walk to school together. Scott, already wrote it, leaves his home at 7 a.m. He meets Johnny and Zach at the end of the block. Next, they meet Paul, Tim, and Pete. Dan and Tori join them 1 block before the school. How many friends walk all together? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. There we go. 8 friends. That's it. It just asked me to do 1 plus 1 plus 1 to get to 8. That's it. But when I'm reading this, if I start assuming that it's like some crazy thing like this guy was, and I start going, okay, so here was Scott, and it's 7 a.m. and then he went this way, and then he met his friends Johnny and Zach. And then he went down another block, and then he saw Paul and Tim and Pete. And then it said he went another block, and then okay, so now I'm making these pictures. I'm getting myself confused. I'm expecting them to ask me, how many blocks did they travel? Or how long did it take them to get there if they started at 7 a.m.? Because I'm making assumptions. That's why we read all the way through.
If it would ask you how long it would take them to get to each block,
Well, if they were talking about time, he would have said, then at 7:02, he found his friends. Then at 7:08, or something like that. They would have given you more times.
Yeah.
Or they would have specified 2 blocks, and then 1 block, and then 3 blocks.
Yeah.
They didn't do any of that. They just gave you a bunch of names, and you had to count the names. Okay? So, the key to this lesson here is 1, find those words. Read it before you do it. I guarantee you it's going to try and trick you. And so we look at it and we go, not today, math. Okay? You got this.